concept remains the same. So what are we doing? The pH of weak acids and weak bases. Alright. The basic method remains the same, that for the acids we calculate pH and for the bases we calculate pOH. Yes or no?
Yeah.
So for the acids when we calculate pH and for the bases we calculate pOH, what do you think we're going to get right here? And then for the pOH, but the questions shall be asking me the weak bases. So I'm going to calculate pH plus pOH equals to 40. But the point is, how would you be able to calculate the pOH? Alright, for weak bases. And on the similar lines, how would you be able to calculate the pH of the weak acid? Right. Now, first of all, you understand what is a weak acid. What is a weak acid? A weak acid is an acid, which does not dissociate completely. Which does not dissociate completely. Yes or no?
Yes.
A weak acid is an acid which does not dissociate completely. Is a weak acid. Is a weak acid. Now, what exactly does that mean? Let's suppose I'm talking about CH3, COOH. Now, when we are talking about this particular acid, the CH3, COOH acid, you see, we generally put it into the category of weak acids, right? We generally put it into the category of weak acids.
Yeah.
Why so? Because if you take 100 molecules of CH3COH, so what do you expect? You expect that all the molecules shall break. Okay, now what do we expect? That all the molecules of CH3COOH shall break. Yes or no?
Yeah.
And when all the molecules of CH3COOH shall break, what exactly happens? What exactly happens? So, how does it exactly break? First of all, see that CH3, COO negative, and H positive, isn't it? So, when we have CH3, COO negative, and H positive, what exactly do you think it would mean? Tell me. That, ma'am, when one molecule of CH3COH breaks, it gives me CH3COO negative and H plus. It gives me CH3COO negative and H plus. Do you understand?
Yes.
So, if 100 molecules of CH3COH would break fully, so I would get what? I will get 100 molecules of CH3CO negative and 100 molecules of H plus. This is my expectation. But in reality, this really does not happen. In reality, if you take 100 molecules of CH3COH,
Yeah.
only 2 or 3 molecules will break. Only
Okay.
2 or 3. So the reality is this. Expectation is what? That, ma'am, 100 molecules I have taken. So 100 molecules should actually break down. Do you understand my point?
Yes.
So in reality, definitely the molecules are breaking down, but only 2 or 3 are breaking out of 100. Do you understand? So when both of them were 100, so it was 0 and 0. And after some time, if 100 molecules, out of 100 molecules, let's suppose 2 break. So we get 2 molecules of CH3CO negative and 2 ions of H plus. Do you understand my point?
Yes.
So what exactly do you think we have? This is 100 ions. So 98 shall be left over. Are you understanding my point? Any doubts in this?
No. Got it.
Okay. So there is this term that we're going to learn here, which is called as the degree of dissociation. So what are we going to say? That let's suppose, ma'am, you take any weak acid, all right? And if that weak acid breaks down, it is going to give me CH3, COO negative plus H positive. So if we have 100 molecules of it, so initially it was 0, 0, time t equals to 0. And when some time passed away, when some time passed away, what exactly happened? So we had 100 minus X molecules have been broken down. So for one molecule of CH3COH, one molecule of CH3CO negative, and one molecule of H plus is coming plus. So only X molecules and X molecules shall be formed. Yes or no?
Yeah.
Do you understand my point? All right. So
Yes.
similarly, if suppose there is another acid, let's suppose some acid H2X, and we say that, okay, ma'am, it is a weak acid. So if it is a weak acid, what exactly is going to happen? It is going to give me 2H plus and X minus 2. But it is a weak acid. That means if you take 100 molecules of this, so at T equals to 0, so no molecule has been broken down. No molecule has been broken down. Yes or no? But if, let's suppose, 100 molecules, out of 100 molecules, let's suppose X molecules break down. X molecules break down. So you just have a look from the equation that one molecule of H2X breaks, it gives me two molecules of two ions of H plus, isn't it?
Yes.
So when it gives me two ions of H plus, what exactly does that mean, Shruti? That means that you are forming, two X ions of H plus and X ions of X negative minus 2. Yes or no? So what is the concept? So we have 100 minus X molecules, and thereby 2X ions of H plus are formed and X ions of X minus 2 ions are formed. Are you understanding my point? Tell me.
Yeah.
What am I trying to tell you here? That, for every weak acid, there is a method, there is a term called degree of dissociation. Degree of dissociation basically means you denote degree of dissociation with the term alpha, the symbol alpha. And degree of dissociation basically means the total turns, the total molecules broken, the total molecules broken over the total molecules taken initially. So in this example, how many molecules do you think we have taken? We have taken initially 100 molecules.
100. Yes.
And let's suppose two molecules break. So 2 out of 100 is going to be my degree of dissociation. Yes or no?
Yes.
If it says 30 molecules are broken down over 100, so I took 100 molecules, but only 30 molecules have been broken down. So that is going to be my degree of dissociation. Yes or no? Any doubts in this?
No.
What I'm trying to tell you right here, what I'm trying to tell you right here, the point here is that degree of dissociation is basically some percentage. If, for example, if I say that 30% has been dissociated, 30% has been dissociated, that basically means what? That 30 molecules out of 100 have been dissociated. You understand?
Yeah.
If I say 45%, percent means 45 out of 100 molecules have been dissociated. Are you understanding? So alpha in reality, if you understand, is a percentage. But every percentage is actually a decimal as well, isn't it? And it is a decimal between 0 and 1. Tell me. If I convert this 45% into a decimal, don't you think I'll be getting 0.45 as my answer? Right?
Yeah.
If I
True.
convert 30%, don't you think as a decimal I will get 0.3? Are you understanding my point? So when I am talking about alpha, you know, the alpha percentage, what do you think it means? Tell me. So when we are talking about the 30% dissociation, 30% has been dissociated. So here I'm going to get the alpha percentage. Do you understand my point?
Yes.
Right? So alpha we are going to consider as a decimal, but in reality consider it as a decimal, but in reality it is a percentage. So weak acids, if I call somebody as a weak electrolyte or weak acid or a weak base, okay, it would be what? It would be less than 30%. It would be less than 30%. Understood or not?
Yes.
All right. This is what you have to understand. Any doubts in this? So now there is a important term that you have to understand. Let's suppose if I say that HF is what? Hydrofluoric acid. HF is hydrofluoric acid. So when we are talking about the hydrofluoric acid, what exactly does that mean? Just see. The hydrofluoric acid is basically an acid which sort of dissociates partially. And I say that its degree of dissociation is generally 5%. But I have taken 0.2 molar of HF. That means this is my concentration C, isn't it? When I say this, I basically mean what? That ma'am, I have HF as 0.2 molar. That means I have 0.2 moles of HF acid. You understand? 0.2
Yes.
moles of HF acid. Where? 0.2 moles of HF acid where? In the beaker. But the rate of dissociation is what? The rate of dissociation is just 5%. 5% of whatever the total molecules that you have taken, or whatever the total molecules you have taken. Like, for example, if I say, only 1% of the population is female. Let's suppose I say this. Now, 1% could be 1% of 1 lakh, 1% of 1 crore. I hope you're understanding. The percentage is still 1%, but that value would be a higher value. 1% of 1 lakh would be what? 1% of 1 lakh would be this. It is going to be 1,000 females. But 1% of 1 crore shall be what? Shall be 1 lakh. Yes or no?
Yes.
So 1% does not matter. What matters is 1% of what value? 1% of
Okay.
what value? On the similar lines, when I say this particular part, you see, when I say the degree of dissociation is 5%, my question to you is that, it is 5% dissociable. That means if you give it 100 moles, 100 molecules, so it is going to have, out of 100 moles, 5 moles shall be dissociated, isn't it? This is
Right.
what
Yes.
exactly it means. So thereby, out of 1 mole, thereby, out of 1 mole, 5 over 100 moles shall be dissociated, isn't it? Right? And thereby, out of 0.2 moles, 5 over 100 into 0.2. These many moles shall be dissociated. I hope you're understanding what I'm trying to explain you.
Yes.
So what is 5 over 100? Don't you think this is the value of C? And what is 0.2? Don't you think this is the value of alpha? This is the, sorry. Don't you think 5 over 100 is what? 5 over 100 is nothing but basically alpha. And 0.2 is nothing but C alpha. Do you understand my point?
Yes.
So C alpha, basically, how do I read it? Alpha percentage of C has been dissociated. Are you understanding my point? Tell me. Any doubts in this?
No.
Sure?
Yeah.
This is the concept. Are you understanding?
Yes.
So this is how basically it sort of works. Understood or not?
Yeah.
Right? Now, similarly, for example, when I say this, when I say HF, and you know that it breaks down as H plus and F negative, and I have taken 0.1 molar HF. So this is going to be my initial concentration. Abhi, initially, out of 0.1 moles, nothing has been broken down. Do you understand? Nothing has been broken down. It is 0.1 molar and nothing has been broken down. I hope you're understanding.
Okay.
But what is happening? When we have HF, HF gives me H plus and F negative. So, and I say that, let us suppose alpha is the degree of dissociation. So, can I say, let us suppose C is my initial concentration? So, at that situation, initially, there was no H and there was no F. Are you understanding? Yes or no?
Yeah.
And then from out of C, C alpha got dissociated, alpha percentage of C got dissociated. How would you read this? How would you read this? Alpha percentage of C. Yes or no? Alpha percentage of C got dissociated. So I'm going to get C alpha and C alpha. Yes or no? I hope you're understanding. So this is the basic concept. Now, because we know this is happening, and also you understand why this is a weak acid. If this would have been a strong acid, then all the molecules of HF would have broken down. All the molecules of HF would have broken down. Okay. And when all the molecules of HF would have broken down, I would have C, yani ki C moles, that means 0.1 moles of H and 0.1 moles of F negative. And I would have 0 moles of HF left. But since it is not fully dissociating, a part of HF is left, basically. So when a part of HF is left, what exactly does that mean? So C minus C alpha is there, so it is going to be C alpha and C alpha. Do you understand my point?
Yeah.
And thereby, what exactly does that mean? You see, I will be left with this. So how do I explain it? That the moment HF tries to break fully, H plus and F negative combines back to form HF. And thereby, it is a reversible reaction. So what I'm trying to tell you, that all the weak acids or bases, all the weak acids or bases, it's not that they do not want to divide or dissociate. All the weak acids and bases want to dissociate. You understand?
Yeah.
But the moment they want to dissociate fully, but the moment they want to dissociate fully, the H plus ions and in this example F minus ions will combine back. Do you understand my point?
Mm-hmm.
And when these ions will combine back, what exactly is going to happen? Just tell me. And when these ions will combine back, what is going to happen? Just tell me. That this seems that this is going to be a weak electrolyte or weak acid. That means weak acids, they do not dissociate fully. So in the beaker, what is happening? What do we find in? we find the dissociated ions along with the undissociated molecules.
Okay. Right.
That's what is happening in the dissociation of the weak acids.
Okay.
Any doubts in this? Say that an equilibrium has been established. So we know that at equilibrium, the concentrations after attaining equilibrium, they do not change. So can I understand this part that, ma'am, when you're writing HF and you say HF is breaking down, you will say H plus and F negative. But you also know this part that, any acid shall break down in the presence of water only. So addition of water is extremely necessary, isn't it? So addition of water is extremely necessary. I hope you're understanding my point.
Yeah.
So at equilibrium, what do we know? At equilibrium, the concentrations shall remain the same, isn't it? At equilibrium, the concentration shall remain the same, isn't it? So when the concentrations they remain same, what exactly does that mean? The concentration of reactants and products. The concentration of reactants and products at equilibrium become constant. Yes or no? Right?
Right.
So what do you think I should write it down? So I can always calculate the K equilibrium, the equilibrium constant according to the equilibrium part I can always calculate. So what do you think it is going to become? I'm going to write down Kc. K equilibrium will be the concentration of H plus ion raised to power 1 because the stoichiometric coefficient is 1 into F negative raised to power 1 because the stoichiometric coefficient is 1 divided by HF, that is 1, that is some value, and the concentration of H2O. So this ratio is going to be my equilibrium constant for a weak acid because for the dissociation of the weak acid, there is always an equilibrium being developed. Are you understanding?
Yeah.
Now you tell me, for water, what have we learned? For water, what have we learned? Tell me. For water, we have learned that for water, we have learned what? We have learned that out of 55 moles, right? Do you remember that? 55.55 moles. Because 1 liter basically is equivalent to 55.55 moles of water. And we knew that, only 10 raised to the minus 7 moles dissociate. So you tell me, 0.10 raised to the minus 7 basically means what? 0.000001. Only these many moles of water shall dissociate. Yes or no?
Yes.
So does that really mean that, this is going to be really, really small value with regards to 55.55 moles of water?
Yeah.
And if this is very small value, what exactly does that mean? That, ma'am, for all practical purposes, for all practical purposes, the concentration of water shall be considered to be shall be constant.
Okay.
All right,
Got it.
the
Yeah.
concentration of water shall be considered as constant,
Okay.
and thereby this H2O we assume is to be a very big constant. So I take this H2O here and I say Kc into the concentration of H2O will give me H plus ion concentration into F negative concentration over the HF concentration. Do you understand this point? And this product of Kc into water's concentration shall be called as a new constant, and that is nothing but Ka. So Ka is going to be H plus into F negative over HF. Do you understand my point?
Yes.
So Ka shall be this value.
Okay.
So what is
So
Ka
K
called?
is only for water.
Ka is called as the dissociation constant of acid.
Okay.
So Ka is called as a dissociation constant of an acid. Do you understand my point?
Yes.
So this is important.
Okay.
So for any particular acid, if I'm writing down HF is in equilibrium with H plus and F negative, and I have some concentration C, so initially nothing was formed. Then out of C minus C alpha, so C alpha and C alpha was formed. So you will say that, ma'am, at equilibrium, the ratio of the product, the concentration of product over HF, because you're adding water to this. Are you understanding?
Yeah.
So here Kc shall be what? H plus into F negative over HF into water. But Kc, but we know that water is a constant. Water's concentration does not change much. So we say that Kc into water shall be H plus into F negative over HF. And this product of Kc into water is called as Ka, which is called as the dissociation constant of an acid. So basically, this dissociation constant of an acid is also nothing but product over reactant. I hope you're understanding. Yes or no?
Yes.
And if it is product over reactant, what exactly does that mean? You tell me. If it is product over reactant, what exactly do you think it is going to mean? Tell me. This H plus into F negative. The product is going to be my H plus and F negative. That means the dissociated parts form the product, and thereby they form the numerator. And HF is going to form the denominator. Yes or no?
Yes.
And when this is going to happen, you understand what is happening. If I say for a certain acid Ka is very high, and what is Ka? Ka is basically this ratio. Yes or no? Ka is basically this ratio. When do you think the Ka value would be higher? When do you think the Ka value would be higher? When the numerator is higher and the denominator is less. And when would you think the Ka value is higher? When the numerator is higher. What is numerator? The dissociated ions are more and the leftover portion is less. HF is what? The leftover portion.
Right.
So that means what? That the more and more the acid shall break down, the more and more H plus and F negative ions shall be formed, and less amount of HF shall be left. Are you understanding?
Yes. Right.
I hope you're understanding my point.
Yeah.
That basically means what? That basically means what? That if any acid has high Ka value, it means it is going to dissociate more. It is going to dissociate more.
Okay.
Do you
Right.
understand my point? And if any
Yeah.
acid has lesser Ka value, that means the numerator is less and the denominator is little high. Yes or no? That means it is a weaker acid. It is a weaker acid. Understood or not?
Yes.
Any doubts in this?
No. Got it.
Right? So this is the concept. So when we are talking about if any acid has higher Ka value, so it is going to dissociate more. And if any acid is going to have a lesser Ka value, that means it is going to be a weaker acid. Understood or not?
Yeah.
Right? Any doubts in this, just tell me. All right. So here, if I put it this way, if I say HF gives me H plus is in equilibrium with H plus and F negative, and I say I have taken initially C concentration, so 0, 0 of H plus and F negative. So out of, C, if C alpha dissociates, C alpha and C alpha shall be formed. And when C alpha and C alpha is actually being formed, what exactly do you think would happen? I'm going to write down Kc as what? H plus ion concentration into F negative concentration over HF concentration. That is going to be my Ka. Yes or no? That is going to be my Ka. So this is going to be C alpha into C alpha over C minus C alpha. Do you understand what I'm doing? Yes or no?
Yeah. Yeah. So,
Because H plus is what? The formed concentration of H plus ions during equilibrium. Did you understand my point? Right? And what is C alpha again? The formed concentration of F negative during the reaction. And what is C minus C alpha? The leftover concentration
yes.
of HF. Do you understand my point?
Yeah.
What exactly does that mean? That means you have C alpha into C alpha over C into 1 minus alpha. So you simply carry C and C. So you have C alpha square over 1 minus alpha, and that is going to be Ka. Yes or no?
Yeah. Correct.
So this Ka is basically going to be C alpha square over 1 minus alpha. And if alpha is very, very less, if alpha is very, very less, that means, only out of 100%, only let's suppose 1%, 2%, 3%, 4%, or 5% has broken down. So 5% is considered to be a lower value, not less than 5%. Okay, not more than 5% is considered as a lesser value. So let us suppose out of a particular solution, if 5 6% is being dissociated, it is a considerable dissociation. If 7% is dissociating, it is again a considerable dissociation. So you have to understand that, if any particular acids dissociation is alpha is being dissociated by 30% or 40%, that means what? That means what? That it is a very strong acid, because the dissociation we are talking about is 30%, 40%. And what is alpha lesser than 1? Very, very less than 1? Approximately 1 to 5%. Approximately 1 to 5%. Yes or no?
Yeah.
So we have this. Any doubts on this? So then we can say that 1 minus alpha is approximately 1. Because if I say 1 minus 0.0000001, so how does it make a difference? It will still remain 1, isn't it? So if alpha is very, very small, what am I going to do? I'm going to say 1 minus alpha is approximately less than equals to 1. So then Ka equals to C alpha square, and 1 minus alpha shall remain 1. So Ka over C shall become alpha square. So alpha shall become under root of Ka over C. Understood or not? Alright. So
Yeah.
alpha is going to be Ka over C. And this is called Ostwald dilution law. And this is called Ostwald dilution law. So you have a look here that, alpha is in inverse proportion with the concentration. Lesser the concentration, more is the alpha. Do you understand my point?
Yeah.
Lesser the concentration, more is the alpha. I hope you're understanding my point. So lesser value of concentration means more value of alpha. Understood or not?
Yeah. Right.
And what do you mean by lesser value of concentration? What do you mean by lesser value of concentration? You tell me. Lesser value of concentration means what? A lesser value of concentration means what? Where you have diluted it. Let's suppose you have a sugar solution. And I say that, that sugar solution is extremely diluted. That means it will not be as sweet, though it is a sugar solution. But in large quantity of water, only small amount of sugar would have been added. Only then it is less concentrated. So same is the thing. But if you add more amount of solute to a solution, you know, the concentration would be what would happen? Tell me. If you add more amount of solute to the solution, what exactly does that mean? Tell me. The concentration would increase and alpha would thereby decrease. That's the mathematical relationship that we have to understand from this. But there is a detailed explanation to that. I hope you're understanding my point up till now.
Yeah.
Okay. So this is
Yeah.
the dissociation of the weak acid. And using this expression, we would be able to do the pH of the strong acid or strong bases. Oh, sorry, weak acids and weak bases. Understood up till now. Is this clear?
Yes.
So now, up till now, you please prepare this part. Tomorrow, we're going to solve the numericals. Okay? This is the basic pH of weak acids and weak bases, right? So, how to
Right.
actually apply this formula, we'll be learning it today. But this much theory we need to know and practice and beat in my head before moving on to the numerical of the pH,
Right.
right?